Morning, guys. Hey, Downey. Hey, Charlie. Long time no see. Hi, Ava. Hey, Azra. Hike. Sean. Hayden. Ryan. Hello. Those of you watching without an email, good morning. Hi, Troy. So today may be a little shorter again because I'm hoping that for a lot of you, the hard part for Tour the Soul System is over with. You've done your research, you've made slides. Today is just kind of recording yourself. And probably the hardest part would be, if you haven't done so already, is putting Screencastify, the extension in Chrome, into your system so that you can use it. Hopefully that is the hardest part. All right. Again, like anytime you got questions throughout the day, I'll either link you back to where you can check a video or I'll answer it if I didn't do that in a video. All right. So Tour of the Solar System is due before midnight, but again, if you finish it early, turn it in early. DNA sheet is due tomorrow. All right. So we are on DNA number 3, and I'll come back to it in a second as you start thinking about it. Define a comet. Kind of in your own mind, what is a comet? And let me get myself out of here. What is a comet in your background knowledge, what you think it is? And then also down below, I put images of some famous comets. I put Halley's in there twice. Oops. Still, go ahead and take a look. The last thing is for end of the class today. It is a form for if you finish Tour of the Solar System early today and you want your presentation shown on stream to be one of our guides of the tour, just fill out first name, last name, what planet you did, and then paste the link in that you get from Screencastify. And then I'm hoping I get at least one person for each planet who wants to volunteer, and we'll kind of have a tour of the solar system tomorrow, a laid back day tomorrow. All right. So again, in your sheet, what's a comet? Looking at these images, that's of Hale Bopp. No, I put Hale Bopp twice, not Halley's. So the first one's Halley's Comet, or Halley's Comet. The second one is Hale Bopp. And the third one is Temple 1. So really 3 pictures there, one's a duplicate. Kind of describe what you're looking at. And I'll come back to those again. After we do our DNA, I will review how to use Screencastify, how to get it into your Chrome book or Chrome on a computer, and then you can record your presentation. Morning, Nikolai. What time is it over there? 7 in the morning. Wonderful, it's Jake Rainey. 7's not bad. You have like a high school day, starting around 7, ending around noon or 1. Distance learning gets a little more truncated. So again, if you're just coming in, we are doing DNA number 3, kind of starting it on your own. I'm going to just talk about some of the images I've put down below, and then I'll help you finalize DNA number 3 as a set of notes. Tomorrow we have one more DNA, and then Friday is just the quiz. I'll help review, I'll post the form, you take your quiz, you're all done. Today is you recording your slides, and then tomorrow, if I have enough volunteers, we'll watch other people's slides. You guys take over the stream. Alright. So a comet. This is one of the more famous ones. This is Halley's or Halley's Comet. Again, probably the biggest thing that you can make out, the most striking feature of really any comet, is this stuff coming off. We call a tail. Some tails are not like others. Each of them are almost a little unique to the comet itself. So that's Halley's or Halley's Comet. It comes every 80-some years in its orbit around the sun. This comet is Hale-Bopp, discovered by 2 astronomers, last name Hale, last name Bopp. That's why it's got that name. This came in the 1990s, before you were born. So when I was a kid, little kid, this was in the night sky for almost a week, like 5 to 6 nights. It had 2 tails, similar to Halley's, a really long debris tail, and then a bright, what we say, ionized tail. So many comets, if they have large tails, they usually have 2 tails together. One is due from the sun, the other one is also due from the sun, but for a different reason that we'll get into in a little bit. So this was pretty cool to see. The orbit for this comet is a little over 3,000 years, so this comet will never come back. You'll never be alive, I'll never be alive to see it come back again. You guys didn't even see it. You'll never see it. This one is more regular, about 80 years. This one's 3,000 years. So right away we can kind of determine that orbits for comets are pretty irregular, but they have a tail. Alright. How about this one? This one does not have a tail. This is Tempel 1. This is a comet. This is not an asteroid, but it's similar, which is kind of what we're going to talk about tomorrow. Asteroids versus comets. Even asteroids that get close to the sun don't always produce a tail. Why? So that's the question I kind of want to get at. Why do comets produce a tail, and how come asteroids don't? What's the difference there? What are you confused about, Jake? That's what we're trying to get at. We're trying to look at pictures and inquire what we're looking at. So I'm making out features that there's a tail. Isn't it just a burning asteroid? No, because an asteroid that's burning up is not producing a tail. There's a difference here, and it's a difference in what they're made out of. A lot of rock and a lot of silicon, a lot of carbon is in asteroids. Comets are a little different, and that's because, like Nikolai said, they're made up of a lot of I'll say water ice, but I mean frozen water. Don't want to confuse Azura. It's water ice. Alright, so this has a lot of water ice on its surface. So what's going to happen to a comet when it gets closer to the sun? If this comet got closer to the sun, what would happen to the ice on the surface of the comet? What do all you think? No, those are shooting stars. Shooting stars are meteorites. Meteorites are little pebbles of rock, or little grains of sand from space that enter the Earth's atmosphere. Much different than what we're talking about here. I say water ice because other compounds can become ice. You can have nitrogen ice. You can have dry ice, which is just carbon dioxide ice. So, yeah, I have to say water ice. Or solid water. So none of you know what's going to happen to this comet once it gets closer to the sun. You don't know what's going to happen to the water. The solidified water. Downey, Hike, Hayden. Help me out here. Close, huh? Oh, Paulie, you're here. So, Nikolai is close to being right. He says this water is going to evaporate the closer it gets to the sun. It's not evaporation, it's something that we call sublimation. We go from ice right to a gas, and it's so explosive that it causes debris to break off from a comet and make the tail. So let's kind of overview a little bit, alright? It'll sublimate and cause the tail. There you go. We have the asteroid belt here. We have Vesta, Psyche, Eros. We looked at some of those yesterday. Ceres is right here. Halley's Comet is out past the asteroid belt. It's out past almost the orbit of Saturn, but it's going to make its return trip back to the inner solar system. So the orbit of this comet is very, very oval-like. Okay? How about we zoom out a little bit? Let's find some other comets, not asteroids. There's Hale-Bopp. Also called the Great Comet of 1997, Hale-Bopp is a large comet, about 37 miles in diameter. Due to its large size, the comet was visible for 18 months in 1996, 1997. It will return in the year 3731. Okay? This is the sun in the center. That's where Hale-Bopp is now. It is past, and it's kind of hard to tell because of the angle it's at. It's almost at the orbit of Neptune, but it's going down. It's descending in the solar system's plane. So, very irregular orbit. This orbit is going up and down. Halley's Comet is going off to the side, but in an oval. They have very weird elliptical orbits, and that brings them very close into the sun. When they become close to the sun, the ice on the comets will basically explode and cause the debris from the comet to make a tail. Asteroids do not make this tail because they don't have the water to cause explosions on the asteroid. There is some water on asteroids, but not enough like we're talking about with comets. Alright, so let's kind of come back and just give it a final definition as a series of notes and discuss what these things are. Alright? A comet is a small, icy, and rocky object with an extreme elliptical orbit. The word elliptical means a more technical way of saying it's a very weird oval. It's a very flat oval. And I'll draw that for you in a second to kind of visualize that. A comet is a small, icy, and rocky object with an extreme elliptical orbit. So we're talking something smaller than most asteroids. We're talking something that has a lot of ice on it, a lot of water on it. And as it gets close to the sun in its extreme orbit, it's going to cause evaporation and what we say sublimation from last year, if you remember that or heard that word. All right. So here's the sun. Here's the Earth in its counterclockwise orbit, right? Well then, here comes mailman's here. Hale-Bopp is coming in at a very extreme oval orbit, coming in towards the sun and then back out. So when Hale-Bopp's here, it has a small tail. As Hale-Bopp gets closer to the sun, that tail gets bigger. As Hale-Bopp is getting to the closest point around the sun, very long tail, lots of ice, lots of debris floating off, but then also some of the gas that it's being produced becomes ionized by the sun, and you get a second tail. So then Hale-Bopp rounds the sun. Not much of a tail anymore. And then there's no tail as it leaves the solar system. Okay. So this is an extreme elliptical orbit. It produces a tail, and then it leaves. Round trip takes 3,000 years. Most comets are in the orbital path of about 3,000 years around the sun. Most comets don't even reach near the sun because they're so far away. I'll show you in a second where they go. So this tail, due to evaporating, sublimating, that's exploding water, water, ice, causing debris. So it's due to evaporating, sublimating water ice that causes debris. I'll get there in a second, Paulie. So these comets usually end up going to a place called the Oort cloud. I'll come back to this in a second. Where's the Oort cloud? Zoom out. The Oort cloud is kind of inside where the Voyagers are. Better way to visualize this, I pulled this up before. 100,000 stars. Here's the inner solar system, outer solar system. Keep zooming out. 1 light year. This is the Oort cloud. See this hazy halo around the sun? All these little objects. These are trillions of comets. Most of them, it's kind of hard to see on a screen. Zooming in doesn't work. Most of these will never end up going into the sun, except for a few, and when they do, they go from looking like this to looking something more like this. Lots of water ice go towards the sun, they look like this. Lots of water ice come in towards the sun, starts exploding with water, sublimating from ice to gas, skipping the liquid phase. It's producing explosions to the point where parts of the comet is casted out as debris, so it leaves a trail of rock, and that trail catches the sunlight and makes a tail. It gets more extreme as it gets closer to the sun. It'll start leaving the sun, and it starts producing less of a tail because there's less energy. And then it goes back to the Oort cloud. If you're Hale-Bopp, a 3,000-year round trip. If you're Halley's Comet, you're not as extreme. You usually go from the inner solar system to the outer solar system. So Halley's Comet is probably an Oort cloud comet that got trapped in by one of the outer giants with its gravity kind of honing it back instead of going back to the Oort cloud. Okay? So that's what a comet is. Again, did you have any real background knowledge? Probably not. But I wanted you to inquire a little bit, because you probably have at least heard the word before, and it is another object in the solar system. Ryan has mentioned another type of object, a meteor or a meteorite. Those are tiny, tiny objects, like the size of your Chromebook, or the size of a pebble, or the size of a grain of sand, and they enter the Earth's atmosphere, and they almost always burn up, and when they do, they produce a streak. And that's the smallest object you can really talk about. A lot of meteor showers and a lot of meteors are produced by the tails of comets. So we have a meteor shower peaking end of this month. We're moving into an old tail of a comet. The Earth is moving in its revolution around the sun into an old tail. Alright, so that is DNA number 3. What's next? Now getting back to the solar system and using Screencastify, setting up your presentation. Unless you guys have more questions about comets. So we are here, DNA number 3, moving into using Screencastify, and then we're going to record our slides. So here's tour of the solar system. I put my Pluto presentation in there just as an example, but I'll do another example right now. Okay? You should have all your research done. All this research was put into a series of slides. Your sources are on the right. Your sources are hopefully somewhere in the slides, either a source per slide or a works cited at the end, a list of all your sources. Your planet name is here. And then up here, you are providing your recording. If you think a recording, you just don't want to do it, you can write out a narration of all your slides. So that's up to you. Some people are just not comfortable in doing that. I'm not going to outright force you to do that, but I just thought it would be easier to record your narration as you're going through your slides than having to write basically a long CER on your planet. So, I mean, it's your choice. I think Screencastify is easier in preventing you from doing all that writing. Or it's a different skill. So using Screencastify, I already have it installed. It's right here, up in the upper right corner. It's a pink arrow pointing to the right. Okay? Screencastify is not a website. It is, again, an extension in Chrome. Extensions are tools. Okay? Another tool maybe that you should use is Web of Trust. I mean, I'm just showing you an extension. Web of Trust tells you if websites are safe or not based on whether they try and steal your information or track you, things like that. That's a tool. That's an extension. Okay? Chrome Remote Desktop allows me to show you my Chromebook. Right? So these are all tools. Screencastify is just another tool. Alright? So I open it up. Asked me to sign into Google. I'm not sure why. I thought I was already logged in. There we go. So I'll click it again. Oh, wait. Yeah. I allowed it. Can I go back now? There we go. So this is the screen you probably see when you click Screencastify. Keep in mind there's a 5-minute limit per video, so you have to keep it under 5 minutes if you don't want to make 2 parts. If you want to give me more information, that's never a bad thing. Just keep in mind you're going to have to break your presentation into 2 parts. You have to stop halfway through and then re-record, restart. Alright? You can choose Browser tab. If I choose Browser tab, it's only going to record this tab right here. It's not going to record the rest of your computer, the rest of your Chromebook. So, Browser tab, alright? And then you click and make sure microphone is on. Alright? So you click and make sure microphone is pink. You don't want the webcam. Alright? I don't need to see your face. Alright? I just want a narration. So you just click microphone, and then you should see this little green bar going up and down, this visualizer of the sound, and that means it's picking up my mic, and it should be automatic for you guys. So you just make sure that's pink, make sure it's Browser tab, you see your voices there being picked up, you're all good. Again, I had to give it permission again. Now it says record, all the same things. I click record. Should give me a countdown. 3, 2, 1. And now it's recording me looking at Tour the Solar System. Okay? If I done my presentation part 1, I could put in presentation part 2. I'm just talking about and clicking around. Alright. I click Screencastify again. Your tab is being recorded. Alright, I can pause it, but I'm going to stop it. I'm done. Right? I went through all my slides. I'm done. Now Screencastify is opening up a new tab. It's showing me the video. I can click and trim it. I can edit it, but I'm not going to. Alright, I'm just going to pause that. And it's got some options over here on the right. You can put it on YouTube. Right? That's kind of like how some teachers are doing YouTube. They publish their videos right to YouTube. They can share it to Classroom. But the one you're interested in right now is the one right here in the upper right corner. Copy, shareable link. And just making sure when I click copy shareable link, people who have the link to the video can view it. So I've already copied it. When I go to Tour the Solar System, I two-finger click it for you guys on a Chromebook, or Control K, and then I just paste Control V the link in, and there's my video. And because you gave me the link, I can see it. Alright? All videos need some time to process, unless it's really, really short like mine. And you can hear my voice. And there's the video, except yours is going to be about your slides. That's really all we're looking for. We're looking for you to be able to present your slides, paraphrase what's on the slide, or put your slide in your own words from your research, and then just send the link to me. I have people sending it to me by email. They're sharing it with me. You don't need to do that. I prefer if you turn it in over the document. But as long as I can get it, whatever. All right? So your questions now. Paula, you had a question about it. If I didn't address it, let me know. Somebody asked me on Remind, do I have to show my face? Can I just use my tab recorder with no webcam? And absolutely. You do not need to show your face. All right? Just your voice is fine. Honorado asked me a question. Can I just do the CR instead? Yes. But I want to see your slides too. Again, I'm just trying to give you a different way of doing something. It's a different skill. Some people are good speakers, some people are good writers. Any other questions? I have the Screencastify video. I know some of you have watched it, but again, those of you who weren't in the chat yesterday, you want to see it again? That is a video I made about using Screencastify. It goes a little more in depth. It actually shows you how to install it because I did not have it on my Chromebook originally. So it was a good opportunity to show you on how to install it. Alright? So I would be showing you that video if you had questions, unless I didn't address it. So I'm here for your questions again. If there's no immediate questions, you're all busy working, doing your own thing, that's fine. I'll just address them as they come up throughout the day. Alright? But just to kind of sum up, this was DNA number 3, talking about comets. Alright, we've talked about asteroids, we've talked about comets. You guys are getting into the details of what makes a planet, right? So the DNAs are about exploring the wider solar system. Tour of the solar system is about looking at the planets themselves, because they are the larger and more feature-rich objects in the solar system. And this is all setting up, maybe can we look at planets outside our solar system for next week. All right. So a lot of information, a lot of little bits. You do have a quiz on Friday, but the quiz should be pretty straightforward if you study. So today is recording your presentation, submitting it to me through the document, pasting the link in before midnight. But when you're done, do it earlier. Tomorrow we are doing DNA number 4, and we are going to take a look at some of the presentations that people volunteered for. Alright? Friday is just the quiz. Monday we start something new. We'll start looking at exoplanets, planets beyond our solar system. When you finish your slides, please don't be shy, because I can guarantee you you did a good job. Volunteer to be one of the guides. First name, last name, what planet did you do, and then a link to your Screencastify. This form is within the daily post today. It's right at the bottom. So this right here brings you to this. This right here brings you that. Not that, that. You all good? Any questions? Immediate questions? Good? All right. See you guys tomorrow. Let me know if you have questions in the meantime. Email and remind's the best way to do so. See you later. Bye, Ryan. Bye, Azra. Early, because you guys don't have questions and you're busy working, so I'll address the questions as they come up. In the meantime, I'll probably drop into Miss Kildoff's meet, see how you guys are doing, if you need any help on the technical side. See you, Randy.